everyone, Mr. Schultz here as we dive into being able to solve polynomials by using algebra. So we have this idea of high degree polynomials. So for example, we could have like something x squared plus 4x plus 2, or let's say plus 4, make it easy. So we could actually try to factor this. So this would be like x plus 2 times the quantity x plus 2. So this is what we call factoring, if you remember from previously. Previously, we were able to just say, hey, we're going to make this equal to 0, and we're going to, after factoring, we can figure out, hey, this will hit the ground when x is equal to -2. If we can't write it as a product of two polynomials, like this right here, or like x plus 3 times the quantity 2x plus 4, just as an example, well then this is called a prime polynomial. Basically, it's prime. Can't factor it anymore. It's done. But we're jumping into the idea of, hey, we are going to be doing that. And in the next few videos, we're going to be talking about that. For example, hey, first thing we're going to deal with is greatest common factor. So we just pull out the greatest common factor. So for example, this 3x minus 12, they both, this term and this term both have a factor of 3 we could pull out. It's like the reverse distributive property right here. That's pretty much what we're doing. So if we look at the next one, like x squared, y squared, we can pull out an x and a y squared from both. Not an x squared, an x to the power of 1. They don't share the x squared, they share 1x, 1 degree of x. We're going to be talking about the difference of two squares. So basically, if you have a squared minus b squared, and then we're going to talk about like the sum of two squares. And guess what? You can't factor it. This would be an example of a prime polynomial. The next one right here is the sum of two cubes. A cubed plus b cubed. And it's only equal to this. Or we're going to be talking about the difference of two cubes. Now we have the square of a binomial or a perfect square trinomial. It's the same thing, but tomato, tomato. Trinomial. So in each case, we could figure this out. Finally, we have this thing called grouping, where we're just going to be like, all right, let's take the first, like let's take these two right here, and let's take these two right here, and try to see if we can pull factors out of those. And then we can, figure out, hey, can we actually factor it? And this is like the last ditch effort right here. We're like, is it going to work or not? All right. All right, guys. Good luck in the next videos. I'll catch you in class. Bye.